And what we're going to do is we're going to look at this concept of matrices and what is a matrix and really define what it is and what it can do in all its different areas. A matrix is a rectangular array of numbers that is usually named by a capital letter A, B, C, and so on. Matrices are often referred to by their dimensions, M cross N, indicating M rows, and N columns. And so that's important to note. We are doing rows cross with our columns. What this does is tell you the size of what a matrix, and we're going to see how that's beneficial. And so I have 3 examples here of matrices. I have matrix A, which is 5, -2, 3. This one is considered the size to be 1 row because your rows are what's moving left and right. Your columns are what's moving up and down. So this would be 1 row by 3 columns. So it would be a 1 by 3 matrix. The next one you can see we're moving vertically. So this is considered 3 rows by 1 column. So a 3 by 1 matrix. The last one has 3 rows and 3 columns. So size-wise, we would call that a 3 by 3 matrix. Now you can do many operations with matrices. We're just going to start with the basics here. We can add and subtract 2 matrices. What's important to note when you're adding and subtracting matrices is only matrices of the same dimensions can be added and subtracted. So like in this example, you can see that it says find the sum and difference of A and B. Well, this is let's see, it has 3 rows and 2 columns. This has 3 rows and 2 columns. And because they're exactly the same dimension or size matrix, we can add and subtract them. If they had not been the same size, we would just say they cannot be added. Does not work. So let's first start with the addition. When I'm adding 2 matrices together, what I'm going to do is I'm going to add and subtract the same area of that matrix. We call either of those an entry. And so I would say, okay, well, let me draw a larger matrix here. So you can see 2 is in the top left-hand corner and 3 is in the top left-hand corner. So I would say 2 plus 3. And what that's going to output is the same size matrix. So I would say 5. Then I'll come to the top right-hand corner, which is 6 plus -2, which totals 4. And so you're adding each individual entry that is the same. So then I'll say 1 plus 1. So 1 plus 1, that gives me a value of 2. 0 and 5. So 0 plus 5 gives me a new entry of 5. 1 and -4. So I'd say 1 plus -4, which gives me -3. -3 and +3. And that gives me 0. So the addition of A plus B, they have to be the same size. And then your result gives you the same size. And now I just want to kind of show you step by step that I'm just taking each piece, adding up those corners, middles, each individual piece, putting them together. Now the same is going to be true for subtraction. If I wanted to say what is A minus B, that means I am subtracting each individual entry. So let's kind of restart with this. And so I would say, okay, 2 minus 3. Now I am going to subtract them in the order that these letters were written. So A was first, so I'm going to write my A entry minus my B entry. So that would give me -1. And then I'm going to say 6 minus -2. Be careful with those negatives. That gives me 8. 1 minus 1, so it gives me 0. Again, I'm just doing 0 minus 5, so it gives me -5. 1 minus -4, so I did 1, subtracting this negative entry, that gives me a +5. -3 minus 3 gives me a -6. So in the case of subtraction, just make sure that your clerical work is very nice, like you don't lose any negatives along the way. So you can add and subtract matrices, no problem, but they have to be the same dimension or same size. Now let's look at multiplying a matrix, and we're going to look at scalar and then sum and then multipliers. And so the first part, let's talk about a scalar multiplier. It's an entry of a matrix that has been multiplied by a scalar. For example, multiply matrix A by the scalar -2. Or they could write this as, what is -2A? When you have a scalar out front, it works just like it did with solving equations and moving things around, you're going to multiply -2 times that entire matrix. So you just distribute that 2 throughout. So it gives me -16, because we are doing -2, -2, -10, -8. So it works a whole lot like what you're doing when you would eliminate parentheses in an equation. So scalar's not too bad. It's just a matter of distributing. The next part gets a little bit more complicated. Adding, subtracting scalar, not a big deal. This one says, multiply the two matrices together. The product of two matrices is only possible when the inner dimensions are the same, meaning that the number of columns of the first matrix is equal to the number of rows of the second matrix. So what you're going to do is order does matter here. If I'm doing A times B, A is first, so I'm going to write its dimensions first. B comes second, so I'm going to write its dimensions second. These two numbers in the middle have to be the same in order to multiply these. If they are not the same, you'll see in how the operation works out, then you cannot multiply them. So let's kind of play through this process. And the best way to teach you how to multiply two matrices together is to just show you with some different numbers so you can see where they're coming from. So in this example, I want to multiply A times B. So the first thing we need to do is check their size. This has 2 rows by 3 columns. This has 3 rows by 2 columns. And because this number is the same on the middle, check, we can multiply these two together. What will happen is the number that are left on the outside will be what size we will get as result. Now, stay with me, possibly jot this down or watch it and then jot it down later. But what we need to do is multiply these two together. So I'm going to go ahead and rewrite them to here. And then I'm going to show you how this is going to work out. I'm going to do a lot of circling and pointing, so if need be, kind of watch through and then go back and jot it down. So in order to multiply these two together, here's how you're going to do it. You are going to multiply, and I'll use my highlighter with this one. You're going to multiply the first row times the first column. What that creates is you do -1 times 5 plus you move to the second piece of this row and the second piece of this column, multiply them. So 2 times -4 plus then you move into this third piece of the row times this third piece of the column. And what we're doing is we're multiplying each piece and adding that together. So then 3 times 2. All together, what that's going to do is once I multiply and add all this together, which gives me -5, let's see, -8, +6, add it together, gives me a result of -7. So you're going to multiply each piece, add all those pieces together to give you one piece of -7. Then you move on and you say, okay, well now I want to do this top row times the second column. So this top row times the second column in the same order of you're going to look at multiplying this piece by this piece, adding it to the next piece times the next piece, plus the last piece times the last piece. And the combination of all that is going to be your next piece. So I would say -1 times -1. So I took this piece, multiplied it by this one. I'm going to add when I move to the second piece. So then I'll say plus 2 times 0 plus 3 times 3. I'll add all that up, and that's going to give me 10. Now, once you get your top row in place, then you move into the next piece and you say, okay, well, now I'm going to do the second row times the first column, and that's going to give me this piece here. Again, each time you're doing this, you're doing 4 times 5, adding it to the 0 times -4, and then adding it to the 5 times 2. So I'm going to say, okay, well, then that would be 4 times 5 plus 0 times -4 plus 5 times 2. Add all that up in your calculator. That gives you a total of 30. Then again, you'll take this bottom row times your next column. So that would be 4 times negative 1 plus 0 times 0 plus 5 times 3. Add that all up in your calculator, give you a total of 11. Now this process is definitely more complicated, but I want you to show you how it works because you do have to have similarity in sizes. We see that with the inner number being the same. The result, again, 2 and 2 are on the outside, so you can see we have a 2 by 2 for our result, and you have to be very meticulous with your details. Now that was just A times B. Let's look at what B times A would produce. You're going to see it written without that parentheses, B times A. So first you look at the sizes. Let's see, our B was a 3 by 2. And our A was a 2 by 3. So because these inner numbers are the same, that means check, I can multiply them. My result is going to be a 3 by 3. And so I'm going to take that process. I'm going to take my B equation, and that's going to give me 5, negative 1, negative 4, 0, 2, 3. And then you're going to multiply it times your A. And I can show you that process, but you know what I want to do next is I do want to show you how technology and how the calculator can help us with this. So let's enter our two matrices from that previous problem. So I'm going to hit new matrix. They're calling this one A. And remember, A had 2 rows and 3 columns, so I'm going to make that a little bit larger. I'm going to enter those values, negative 1, 2, 3, 4, 0, 5. And so I've got matrix A in there. I'll just hit enter. It'll save that. I'll do another new matrix. My matrix B was a 3 by 2, so I need 3 rows and 2 columns. I'm going to enter that matrices as we wrote down. So I've got 0 and I've got 3. So now that I have A and B in there, I can actually multiply these out, and I can do all my operations on this calculator. With this one, I'm wanting to specifically show you how to work out multiplication. And so I'm going to say, okay, well then I'm just going to select B, the letter, and A, not putting anything in between them, just like what we have written. And you can see that result, which we knew the inner number being a 2 made it where we can multiply it. The outer number was the result. So you can see this definitely sums up that process, but I want to show you how to enter that on the matrix calculator.